All right, question number 10. In a survey, it was found 68% of adults operate the flusher of toilets in public restrooms with their foot. If 400 adults are randomly selected, how many would we expect to flush the toilets in public restrooms with their foot? Would it be unusual to observe 320 who flush with their foot? So 68% operated with their foot. How many would we expect out of 400? So expect, this is dealing with expected value or the mean. So we are given that n is equal to 400. Our probability of using this with our foot is going to be 0.68. And so to find the mean, we would multiply n times p, which would be our 400 times 0.68. So if 400 people were to do this, we would expect, I lost my calculator. We would expect 400, let me clear this out, 400 times 0.68. About 272. We would expect about 272 to use it with their foot on average. And it says, would it be unusual to observe 320 who flush with their foot? So what is the probability that 320 would do this? So probability that x equals 320. What's the probability? So we're going to use our StatCrunch app. We are going to do our calculator, binomial calculator. So we're going to have 400 trials, probability of success 0.68. We want to be 320. We want exactly 320. So the chance that exactly 320 would do this would be 0.000, like almost zero. It's so small. So would it be unusual to observe 320 who flush it with their foot? Choose the correct answer. We're going to say yes. And so the way that they're looking at this, it looks like they're trying to do the empirical rule. So 320 is greater than the mean plus 2 sigma. Okay, so let's look at the way we're explaining this here. So since we have more than 400, which we'll learn later, since we have more than 30, 30 is about the number that we look at to see if it's normal. As you can see, when I put those numbers into StatCrunch right here, you can see this looks like a normal curve. So what we're wanting to do is compare this with our standard deviation. So if we're thinking bell curve, and we just found the mean, previous problem was 272. Then let's find the standard deviation. So the standard deviation, sigma, is equal to the square root of n times p times 1 minus p, which is the success and failure rate. So we're going to figure out sigma. Sigma would be 400 times 0.68, and then 1 minus 0.68 will be 0.32. So let's figure out our standard deviation. Second square root, 400 times 0.68 times 0.32. And that gives us roughly, let's say 9.3. So if I were to add 9.3, that would put me at 279.3. No, add 9. 281.3. And if you add the sigma to that, add another 9.3, that will put us at 290.6. You can just do that math real quick. Let's just double check. And we got 270. I'm going to enter that, and we're going to say plus 9.3. And then enter. So, wrong number. 272. 272. And then plus 9.3. 281, and then do it again, 290.6. Okay, so on the other end, if I subtract this 272, and then I subtract 9.3, we get 262.7 and 253. So we can see 95% of the data would be between these two based on the empirical rule. So we're looking at 262.7, and over here we're looking at 253.4. Okay, so empirical rule says all this area right here between two standard deviations of the mean is about 95% of your data. So anything outside of the 95% would fall into that less than 5% chance range. Okay, that's why they're looking at two standard deviations to the left and to the right, because the empirical rule says 2 on either side is 95%. So anything that falls in the outer region would make up the other 5%, and that's a smaller chance of that happening. So based on that, 320 is outside of the two standard deviations, which means it's going to be smaller than the 5% chance. So would it be unusual? Yes, because 320 is between, no. Yes, 320 is greater than this, which means it's going to be outside and smaller than 5%. So we're looking at D.